Everyone, welcome back to my channel. So, have you ever wondered how machine learning makes, let's say, a great prediction? How does algorithm make a better with each step, and why the gradient boosting is one of the most technical in machine learning? So, in today, I will try to break down gradient boosting with a simple example, so you will not only understand it perfectly, but you can also you will be able to even to implement it yourself with pure Python. So imagine you are trying, let's say, just give this motivation to this boosting, gradient boosting. So gradient boosting is an ensemble learning technique that build multiple weeks model in a sequence. Each model fixes the error of the previous one, making the predictions, let's say, more accurate step by step. Now let's dive now in action and to see how it's working with a simple data set. So before that, if you are not subscribed to my channel, please do subscribe in my channel and like the video. And if you have any question, drop a comment in a comment. Drop a comment, of course, in a comment below, so I will answer it because this preparing this takes much time. So as we already defined the gradient boosting, it's in ensemble learning algorithm that build multiple weak models. You can see in this figure is taken from Geeks, Frogs. It's hard to pronounce this, but this website is famous, and you can have a look on this website, of course. So you can see, for instance, we have a data set here, and start a model with a decision tree with only one split. So it's only one node in the tree, and then you will calculate the error, or called residual, of the model of this model here, and your model will train the to predict these residual. So usually when we have a training when we have an algorithm, it will try to train and to predict the class label, or let's say the regression value. But here it's try to calculate to predict the residuals that calculated from the previous model, or let's say weak classifier. So this process continuously, iteratively, and keep adding models to reduce the error. As you can see here, final model will try to fit the data, as you can see in this tree. So let's assume that we have this data set, so X and Y target. So what we can do in the first step, we'll start with initialize the prediction. So we will sum up all of these the class labels. Let's see, this example, or this video, it's only for the regression. For the classification, I can do it in the next session. So we start with the initial prediction, and you can see sum up all of these y target values and take the average value. Now this is, let's see, the prediction, the initial prediction of the y. So you can see here, this is x and this is our y. Initial prediction, this is, for instance, 8. All the values will be 8. And now you can calculate the residual or error, this minus this. Now this error here will be as let's see, it's not as a class label, but let's see, just for simplicity, it will be as a class label. So we will try now to predict what is the we will try to predict these errors. So now let's say this is our data set here, and instead of y, we will replace it with the residual, or let's say the error of the first classifier, weak classifier. Now assume the decision tree is classified as, it will be -2 if x less than 2.5, or +2 if it's greater than 2.5. This is only an example. So after this, you will have a decision tree to classify this, to predict this, and then let's see, this is the prediction. Now we will update the prediction here. So the prediction, we will see, let's assume that the learning rate is 0.5. And with this equation here, we can add the initial prediction plus lambda multiplied by R1, which R1 is this one here, the prediction of the decision tree. Let's see, this is a decision tree. And you can see this is a prediction. This is the first tree, which we have calculated from this one here. And now we need to update the the y hat, with this formula here. And you can see this will be 7799. And now we will try to calculate, to let's say, to predict this target. And we have the update of our updated prediction was 77 from this one here. And you can see now the residual of this predictions is minus, I mean this minus this. And you can see the next classifier will try to predict these residuals. And we see, for instance, this is the second residual, minus 200 plus 2. And we will have, I mean, calculate the final prediction with this equation here, with this y hat. And it's just iteratively until finding the closest, let's say, values to the class label. And you can see, for instance, this is the class label, our class label. Let me just check if it was the class label. Yeah, for instance, this is the class label. And if you see, after two iterations, we have somehow close to the class label. So it's 5 and 6, 7, 7, and 9 and 10. And here we have, let's see, minus 1. I mean, after iterative, you will have somehow close result to this. So as I said, this is a regression model. So as a summary, start with the initial guess, which is, in our case, we have done here, is a mean, and compute the residual, train a weak classifier, update, repeat, and final model will try. Let's see, it's just sum all of these weak learners. So there are many, let's see, not many, but several gradient boosting algorithms. It's like gradient boosting machine, this one here, and XGBoost, which is, this is the most, let's say, fastest and optimized speed for and the performance. I will also explain it in a more detail with a simple example, as you can see this one in the next videos. And when to use gradient boosting? So it's suitable for small and medium data set, not for the big data set. So you can use it if you would like to have a high accuracy, and when your data has I mean have no nonlinear relation in the data. I also, as usual, I have added this Python code here, and you can see I have imported gradient boosting regressor from the ensemble. And if you would like to use a classifier, of course, you need to replace this with gradient classifier. And you can see this is only reflecting the data that is used in this document here. And yeah, this is, you need just to import this, and that's it. Of course, you need number of trees, learning rate, and maximum depth of the tree. It should be one, let's say one. And that's it for today. And if you like this video, please subscribe to my channel and like the video. If you have also a question, please drop it down in the comment below. I will answer it. And by the way, next time I will try to integrate. I have first the classification, the gradient posting for classification, how it's working with a simple example, and how to integrate this in a let's see, in our project, which is already implemented in this classification project. You can see base classifier here. Okay, then happy learning and see you next time.